Hello everyone. In this video, we are going to see what is style transfer. We will have to get a deeper understanding of how convolutional neural networks and its layers work. Before we go to our style transfer application, let's clarify what we are striving to achieve. Let's define a style transfer as a process of modifying the style of an image while still preserving the content. Given an input image and a style image, we can compute an output image with the original content, but a new style. It was outlined in Leon A. Giddy's paper, A Neural Algorithm of Article Style, which is a great publication, and you should definitely check it out. Convolutional neural networks are deep learning subjects that we can come across with tens and maybe more models defined for hundreds of different problems that have proven their success in computer vision. We know that these are used in vision systems of robots and autonomous vehicles, such as face, object, traffic sign recognition. What is VGG? VGG is Basic Level Convolutional Neural Network Model, which allows us to use content and style of an image individually. And that's exactly what we want. How does it work? First of all, we take input image and style images and resize them to equal shapes. Then we load pre-trained convolutional neural network, for example VGG16. Knowing that, we can distinguish layers that are responsible for the style, basic shapes, colors, etc., and the ones responsible for the content, image-specific features. We can separate the layers to independently work on the content and style. Then we set our task as an optimization problem, where we are going to minimize content loss, that distance between the input and output images, which is we strive to preserve the content. Style loss, that distance between the style and output images, which is we strive to apply a new style. Total variation loss, regularization, spatial smoothness to denoise the output image. Finally, we set our gradients and optimize with the LBFGS algorithm. Let's go straight to the code. Let's start with defining our input. Then let's define a style image. Next step would be to perform reshaping and mean normalization on both images. Afterward, with our image arrays ready to go, we can proceed to our CNN model. In this project, we are going to use a pre-trained VGG16 model, which looks as this one. In here, we are using the black and red ones, not the others. Having our CNN model defined, let's define a content loss function. In order to preserve original content, we are going to minimize the distance between input image and output image. Similarly to content loss, style loss is also defined as distance between two images. However, in order to apply a new style, style loss is defined as distance between the style image and output image. In here, we use gram matrix to obtain the representation of the style image. It is necessary to calculate the correlation between different types of neural network using gram matrix. Lastly, we are going to define a total variation loss, which is going to act as spatial smoother to regularize image and prevent its noising. Afterward, having our content loss, style loss, and total variation loss set, we can define our style transfer process as an optimization problem where we are going to minimize our global loss, which is combination of content, style, and total variation losses. In each iteration, we are going to create an output image so that the distance between output and input, style on corresponding feature layers is minimized. Ultimately, let's optimize with the LBFGS algorithm and visualize the results. In here, first picture is output after one iteration, second one after two iteration, and third one after 5 iteration. Let's see how our input, style, and output images look combined. We can clearly see that while the original content of the input image was preserved, we successfully applied a new style to the output image. Thanks for watching.